some remarks about vectorization and what is needed to handle the two DSP codes that we saw for SIMD vectorization. First, as I mentioned before, some initial optimizations such as copy and constant propagation, and then the loop tree is constructed from the control flow graph. What is very important then is to get rid of pointers, namely rewriting pointer expressions into array references. And that is done in a way which is, in some sense, similar to operator strength reduction, namely that we analyze the SSA graph and identify induction variables and can reconstruct what looks like an array reference. Okay, and then we identify which statements, source code level statements, are in each basic block, and construct the data dependence graph and the data dependence matrix and perform unimodular transformations if useful. What's obviously also important is to see which through address code statements can be mapped to SIMD instructions. So if we rewrite this code into array to use array references, it should actually look like this. So this is what the code actually says. And in the next case here, we see that the code doesn't look so bad when we see it in this way. Okay. So other things, all arrays except those in structs are aligned on 16-byte boundaries, which helps the compiler. And for non-aligned references, there is still only one load used by pipelining the two loads that we saw before. Namely, to reuse the second load by letting it be the first load in the next iteration. Okay, and such instructions are moved out of loops, and then to do that, it's important that it's the first, I mean the value produced by these instructions is the same, and to be able to move them out, it's important that the input to them also is the same. Otherwise the compiler doesn't, SSA pre doesn't understand that they produce the same control instruction for vector permute unless their input sources are identical. So therefore we use only the first array element for this. Okay.